What's up, what's up, what's up? It's your boy, the network. And today's topic is section 3.9, configure and verify filtering with any protocol. No, this is not Groundhog's Day. This is a totally new video. It's just that it's the same topic as the last video, but this is part 2. We're going to be doing filtering routes using prefix lists. So we're doing distribute list, but we're distributing prefix lists. This is a topic in the CCNP ROUTE Exam, exam code 300-101 version 2.0. Let's take a look at the exam blueprint to see where we came from and where we're headed. All right, so this is the exam blueprint, implementing Cisco IP routing, exam code 300-101. We just wrapped up the same section, 3.9, but we're doing part 2 of this section because I didn't want to put all 3 ways of filtering routes in one video. It would have been one long video. Remember, I'm trying to do this like a nugget, if you will. I'm following somebody else's blueprint. So again, we're doing configure and verify and filtering with any protocol, but we are going to be filtering using prefix lists. After this, we're going to move on actually to the next topic, which is configure and verify redistribution between routing protocols or routing sources, because there is one more way to filter routes, and that is route maps. But again, that is a totally different objective. We will cover route maps in that video. Let's move on to the slides. Again, think of the last video that we talked about what route filtering is, right? The route filtering is similar to a bouncer or security guard at a nightclub. He's filtering people coming into the club, and he's actually filtering, being selective with who can come out and into the club the other way. Basically, he's filtering both ways. He's looking at the dress code. He's looking if they look presentable, if they don't look like knuckleheads or whatever. That's what filtering does. And the reason why we want to do this, let's go over to the next slide and we'll talk about that. Again, route filtering, if you want to pause this and look at it, this is the definition. I didn't really like this definition, but it again is from Wikipedia. I'm not going to talk about what route filtering is again because we talked about it in the last video if you want a full definition. Or you can pause it, freeze frame it here. There's 6 ways to control routing updates, like we said in the last video. The top 3 are the simple ways: passive interface, we did a video on that. Default routes, we did a video on that. Static routes, we did a video on that. The bottom 3 are the advanced ways to filter routes. Route maps, we are going to do a video on that. I believe that's section 3.14, explain route maps. And distribute lists, with this distribute list allows an access list to be applied to routing updates, but we also use the distribute list to also distribute route maps, access control lists, like we did in the last video, or prefix lists. So remember, you create the route map or the ACL or the prefix list, and then you distribute it. I will show you. I had that kind of difficulty. I say this a million times because that's how I'm going to try to remember it when I watch these videos. Again, distribute lists define the traffic filtering requirements to permit or deny routes using one of these 3 methods, like we just said: ACLs, route maps, which will be covered in 3.14, configuring a prefix list, which we'll be covering today. This image, we talked about this in the last video too. I'm just going to run through these slides so we can get straight to hands-on, because that's the fun part, getting our hands dirty. IP prefix filters, that's what we need to cover. This is a new slide. Traditionally, IP prefix filters were implemented with IP access lists, configured with the distribute list command. Think of prefix lists as the, it's kind of like the, an access control list, but it's different because you don't have to use wildcard mask. You just put in the CIDR notation of the subnet mask. When we're using the real life example, in my case, the nightclub or the bouncer, the bouncer's RSVP list, that's his prefix lists. So think of it that way. If you don't see that person's name on the list, guess what? You ain't getting in the club. Prefix lists they have better performance than access lists. They're actually easier to manipulate. You'll see, like it just says right here, user-friendly CLI. Access control lists, they have to be done in sequences. There's an implicit deny at the end of them. You have to make sure they are in the correct order, or else they will contradict themselves. It's easier to do prefix filters. You could also match routes in part of an address space with a subnet mask that is longer or shorter than a set number. You will see this. There's this an or operation. If you don't know what an and, if you know about computing, I'll probably leave a link in the description below on what the difference between the and or operation is. In this case, there's an or operation called less than or equal to and greater than or equal to. We'll cover that in a little bit. That's the most powerful thing about prefix filters, or the neatest feature of them. This is exactly what I was talking about. The or operation. You can filter by exact prefix length by just putting the CIDR notation of the subnet mask. So I'll show you on when we do hands-on, right? The subnet and then the subnet mask, and you will be filtering using that exact subnet. or you can filter within a range. This is the neatest feature of prefix filters because you can choose how much of the subnet you want to match by using GE for greater or equal to, or LE for less than or equal to, or you can use both and do greater or equal to and less than or equal to. I haven't really experimented with that third feature. I may try it in this video. The matching process also considers the subnet mask, and that's what the GE and LE does. So here's a generic syntax of a prefix list. It's similar to access lists, like I said earlier. It's similar to ACLs, but with no wildcard bits. And I don't know about y'all. I know there's only a certain amount of wildcard bits you really need to know, wildcard masks that you really need to know. But I don't like working with them. This is a lot easier. So you go into config mode, type in IP prefix list. You name the list, in this case, match list. That was creative. And then permit. And then you put down which subnet you want to permit. In this case, 172.16.0.0. And then the subnet mask insider notation, right? So if you look at this prefix list right here, definition of one, it's asking which prefixes are matched. The first one, which is 172.16/16, that's a match because that's the exact subnet we're going to allow. That permit tells you that's what we're allowing. We're saying, okay, all you ladies that's dressed in red, y'all can come in. So that means everybody that's dressed in black, pink, purple, whatever, they can't come in. That's basically what this is because we're saying exactly what we want to allow into our nightclub. The bottom two, no match, right? 172.16.0.0/20. You a /20. You got polka dots. You can't come in the club. /16.2.0/24. You can't come in because you got the wrong subnet, or basically you got a hat on. There's no match. So, or you looking on the RSVP list, you just can't come in the club. I know, I got these crazy ways, but that's how, like I said, that's how we remember it. And hey, I'll be passing the exam. So a prefix list entry with the GE or LE keyword matches any prefix within a specified address space for which the subnet mask falls within the specified limit. So we got two examples right here. The top one says you go to config mode, IP prefix list, name the list. You put list A. Permit what you want to permit. In this case, 192.168.0.0/16. And then this is the neat part of it. LE20. So you're saying you're allowing permit 192.168.0.0 subnet with a /16 subnet. Or remember, this is an or operation, or less than or equal to /20. So anything between a /16 and /20 subnet mask will be allowed. You can also write multiple prefix lists to create certain rules. So again, this is like the RSVP list, but we're combining them. Okay, the party of fours, the Taylor family, the whatever. You know, you're just creating rules and making them on the RSVP list. Whatever. People that's dressed in black, whatever the case may be. In this case, for the first one, we're just going with the first one. List 1 is a match with 192.168.0.0/16, right? Because /16 is /16, obviously, right here. And it's also less than or equal to 20. So that will match. This bottom one here, list 2, says 16 greater than or equal to 18. So we're allowing 16, but greater than or equal to 18. So in other words, 16 is not greater than or equal to 18. So there's no match there. That will actually be denied. You'll be denying anything that's greater than or equal to 16. Here's some other special prefix lists. We will actually cover that when we do hands-on. If you do the first one, you are permitting any route. You go into config mode, IP prefix list, name the list. In this case, I named it bruh5. Permit, and then quad 0/0. That's basically what? A default route, right? And then you're doing less than or equal to 32. So that means less than or equal to subnet mask of 32. So that's really the wild card is quad 0 also. So quad 0, you're allowing any route to come through. Why would you do that when you would just don't even make it? Don't even make a prefix list. You just leave it blank. But you're kind of filtering in a way. You can permit the default route. This is the second one. You use that syntax. IP prefix list 7. Permit and then quad 0/0, and then you just leave it as is. That's going to permit the default route. We'll cover that too. And remember, there's an implicit deny at the end, just like access. Let's go ahead and spin up GNS3 and play with prefix lists. We're going to use the same topology as last video. We got loopbacks, configured on router 2, which is this guy on the right hand side. And then we also got router 1, who will be receiving or learning about these routes through an EIG process, EIGRP autonomous system. I've been saying process in the last video. Remember, EIGRP is defined by autonomous system. These two routers are participating in EIGRP AS number 1. Router 1 on the left-hand side will be learning these routes through this interface. Let's go ahead and console into router 1 and see what routes he's got so far. Do show IP route. And he's got all of these routes here. For this video, I created a default route and added it right here. This is a static route, right? Let's create a prefix list that will allow, we're going to allow the, let's allow this 172.16.50.0/25 route in. Let's just filter that route and deny everything else. So the way you would do that is IP prefix list. You're going to name the prefix. So in this case, we're going to name it BRA15. After that, you will we're going to permit just this route. You put the IP address and the subnet mask. That's the difference between this and an access control list. You don't have to put wildcard bits. You just put in the IP address and then the subnet mask insider notation. So in this case, 172.16.50.0/25. After that, you could do greater than or equal to or less than or equal to. But in this case, we're just going to do just that subnet. We're not gonna. We'll do those OR operations in a little bit. After you do this, you same thing as access control lists. You would create the prefix list and then distribute the list. So let's go ahead and do that. We will go into router config mode. So router EIGRP1 in this case. Then you would distribute list. In this case, and here's the type of list you can distribute. In this case, we're going to do a prefix. The prefix name was BRA15. We are going to do it on incoming routes. We're going to filter this as an incoming update. And you could put in a specific interface, or you could just do, if you leave it blank, it'll do all interfaces. After that, EIGRP should sync. And there it's resync. And let's go ahead and check the routing table. Do show IP route. You can see we filtered just the 172.16.50.0 network. Everything else has been filtered out. We still have this connected route still there. That's because it's physically connected to us. We still have our static route. We statically entered that. It wasn't dynamically learned. That's why it's not filtering it. So the only thing that's really left is this dynamically learned EIGRP route. Let's run another show command. Do show IP prefix. And you can see there's one entry right there. Let's do another one. Okay, now we are back in with a clean slate. Let's play with the OR operation, the less than or greater than or equal to. Let's do a show IP route, see what we're working with so far again. All right, so let's play with the 172. Let's continue picking on this network here. Let's filter all the routes in the 16.4.0 network, but /24, right? So these guys are all in /24. But let's say we don't want anything more than 24. So we just want to continue just filtering. We just want to keep these routes right here, right? Because these are /24. Everything else is not. So we need to do, we've got a /26. 25, 28, etc., right? So anything greater than or equal to 24, we want to deny those. Let's do that. So now we got a clean slate. IP prefix list is the syntax, right? Let's name this one BRA10. We are going to permit. We're going to do permit. The what do we want to do? We want to permit this subnet, right? 172.16.16, right? And we're going to do, so notice these are options here. A minimum prefix to be matched or maximum prefix to be matched. In this case, we're going to do, we wanted to do less than 24, right? So we want to do less than or equal to 24, right? So now after you create the prefix list, what do you do next? You distribute it.
I'll make it rain all day long.
Go to router config mode. I remembered it that time. EIGRP 1 and do distribute list. This is a prefix. We are going to reference the prefix list, which was bruh10. We want to do incoming, and let's just, in this case, let's specify which one we're going to filter routes on. Fast Ethernet 0/0. Wait till EIGRP resyncs itself. And there it goes. Let's do a show IP route. And notice we only have subnet masks that match between 16 and 24. These only the ones that are matched. Remember, it's at 16, right? But we're saying greater than 16 or 24. The other ones were 25, 27, etc. You notice that? That's pretty cool, right? Let's do some special ones. Let's remove those out. Actually, let's run some show commands. Let's get out of this. Let's do a show IP prefix lists. And see, you can see there's our prefix list right there, bruh10. There's one entry. We permitting /172.16.0.0/16 less than or equal to 24. That's what that did right there, essentially. That's what this did, right? Y'all see that? This entry right here, prefix list. We minimized our routing tables. Remember, when we do this, we're minimizing our routing tables, so the router will use less of its CPU because there's not too many routes to let in the club, essentially. We got a capacity. We're like a fire marshal. We got a capacity of X amount of people we can let into this club. And that's what we're trying to do here.
We have thousands of people outside trying to get in, and we have a fire marshal that says, oh, we can't allow more people.
Okay, so I removed the other commands by doing no and no. There goes that EIGRP message. And notice, this is a level 5 message. It's just informational, kind of. Recent route configuration changed. That's what that message is. Let's permit our default route. Let's do a show IP route. Right? Here's our default route. Gateway of last resort is 192.168.12.2 to network quad 0, right? That's this route, essentially, right? Our next hop is this router. That's 12.2, right? We're going to make sure that this is the only route we have in our routing table. We do this, we're going to get rid of everything else in here, right? So we should be left with one. Let's go ahead to, do you remember the syntax for this? Pop quiz. Pause it right here and think about it. We back. It's IP prefix list, right? You name the list. We're going to name this one bruh20. And we're going to permit, in this case, it's quad 0. So, and then /0. That's going to be our default route. LE32 is permitting any route. So in this case, permit quad 0/0. Right now, after you create the prefix list, what do you do?
I'll make it rain all day long.
You distribute the list. Go to router config mode, router EIGRP 1, distribute list prefix bruh20. We're doing inbound. Let's do it on all interfaces, right? Do that. We should wait for EIGRP to resync. And there you go. Now, if we do a show IP route, let's run a couple more show commands, right? We've essentially removed our default. We have the connected route, so that has to be in there. I don't know. We should try to see if we can filter out a directly connected route too. I doubt you can, because we're physically connected to it. Maybe we could, maybe we can't. I don't know. But essentially, we just kept our static route here, our default route. Let's remove the other routes. No and no. I will edit that out. Actually, let's do this. We need to, because we're configuring and verifying. Let's verify it. Let's do that. Do show IP prefix, and there's our prefix list. This is allowing only the default routes. So yeah, that is distributing prefix list. In the next video, we will be moving on to the next topic. If you like this video, please comment, like, subscribe to the network. And don't forget to click that notification bell next to the subscribe button so that way you know when I'm putting these new videos out.